Hello, my name is Matt LeBlanc. I'm a systems engineer here at Avesha. Today, I'm going to talk to you about a new innovative technology from Avesha called KubeSlice. And in this demo, we're going to be talking about how to keep PacMan alive. Now, I've using that theme to as this application that we're going to protect that data. And in this case, we're going to be using PacMan along with Mongo database and 3 replica sets. And though that Mongo database replica set will be run across GKE, AKS, and EKS. Now, before we get into the demonstration, we need to go over some background. So first, what is KubeSlice? Well, quite simply, KubeSlice is a cloud-native solution which allows you to securely connect, manage, and monitor connectivity to those clusters across any cloud and or on-prem with any flavor of Kubernetes. And as a cloud-native application, it is deployed as an operator, and in our case, via Helm chart. Now, what does it mean to create a KubeSlice? Well, it basically connects your clusters via that global namespace. We create a VPN connection via layer 3 networking and create a private IP address and DNS, allowing for very secure connectivity, connecting your namespaces in a global fashion. Now, in this particular use case, we're going to take advantage of KubeSlice's ability to connect those 3 databases across 2 different clouds. So in this case, we're going to deploy PacMan and Mongo database across those 3 clusters of GKE, AKS, and EKS. We're then going to kill a pod, kill the pod that is running Mongo database in that particular cluster, and that's going to be simulating an outage or the cloud is unavailable. And then we don't need to do anything, but KubeSlice will basically allow for that Mongo database multi-cluster instance to fail over to one of these secondary replica sets. Now, why is this important? Well, we have seen a lot of outages. The hyperscalers are not 100% resilient, and we do know that there is outages across all 3 of them. So whether it's AWS or Azure or Google, we have seen certainly plenty of documented outages. So having a plan will allow you to have greater resilience for your applications. Now, in this case, this is the dashboard for the Mongo database operator, and I have 3 instances. And what we see here is we have our primary replica set over here on the right, which is now currently labeled as Mongo replica set 2.0. And then we have 2 other replica sets. So those are considered to be secondary. And in this case, our primary replica set will be read-write, and our secondaries will be read-only. In the event that that primary read-write replica set goes away, we will be able to promote one of the other 2 to become its primary. Now, let me give you a little explanation as to how this is set up. Each PacMan instance is installed locally on each cluster, so across Google, Azure, and AWS. The high scores are running on that multi-cluster Mongo replica set. So we have the primary that is running read-write, we have the secondary that is read-only, and once a failover happens, one of the secondaries will become the primary if that cluster goes down. Now, the setup is pretty easy. We have 3 clusters, AKS, EKS, and GKE, all running current versions of 1.23 or 1.24 Kubernetes. We're running the current instance of KubeSlice. This is as of August 2023, which is version 1.3. We're running MongoDB multi-cluster 6.05, and you can find the details of that PacMan installation. Now, it is important to note that PacMan was originally a version that supported Mongo 3, and obviously we're running 6.0, so there was a little bit of adjustment to make this work. Now that we've reviewed our background of what we're doing, let's get into it. All right, so now we're going to go through the demo here. Let's go through the KubeSlice Enterprise Edition dashboard. Again, what you see here is our deployment map, and we're looking at our GCP, our GKE cluster in Google Cloud. We have our AKS cluster in Azure, and we have our EKS cluster in AWS. And what we've done is created a slice. Now, a slice is quite simply connecting those namespaces via an encrypted environment. It has a private DNS and private addresses, so it's not routable and it is secure. So we've created a MongoDB slice which connects those three clusters across Google, Azure, and AWS. And we have shared the namespace MongoDB amongst those three clusters. That is how it's set up. Now, let me show you the next piece is we have our PacMan application, which you can see here in the background, and the database that is keeping the scores of these here. So if I go to high scores, you can see that all these are running across all those clusters, but the database is shared amongst those three locations. So if I go over to the MongoDB Operations Manager platform, you can see that we have our three replica sets. So we have replica set 0, replica set 1, and replica set 2. Now, each one of those replica sets, copy of the database, is running within the clusters. So let's switch over to my Lens environment. So this allows me to manage each of my clusters here. And if I go over to our EKS cluster, take a look at the pods, and you can see that EKS is running that replica set 00 that we just saw a moment ago. Our Google cluster is supporting the replica set 1, and our Azure cluster is supporting replica set 2. Now let's go back and play a little PacMan, show you where the data is coming from. So if we go back here, you can see I'm in the AWS deployment, and I'm quite simply going to click play and add some data to that environment. Now, before I do that, let's make sure. The lowest high score is 190. So I basically need to make 300 to put in 3 new scores on there. So new, okay. And you can watch me play. Now I have a score that is worth keeping. I can now put it up here. So note, we are in AWS. We're going to put the time 3:41 p.m. and hit save. And you can see AWS 3:41 p.m. is saved in the high score. Now, if I go over to our Google deployment, you'll also see that is also in there, right? AWS 3:41. So let's add some data from this side. New, okay. All right, we've now saved our game. GCP at 3:42 p.m. Save. View list. And we have our GCP at GCP 3:42. Oh, made the top. Fantastic. All right. So now we have that score, and we're going to go one more. And again, play this out. All right, now we have our final score here. We're going to call this Azure 3:43 p.m. and save. View list, and look at that. Azure 3:43 p.m. All right, so we now have our data that we want to save. So now let's break something. So we are going to go over to my Kubernetes console, and if you remember correctly, go back here, look at our Mongo server. And if you see the Mongo server, where our primary, see our replica set, that primary replica set is running on set number 1. So go over here, replica set 0, there's replica set 1. So before I break this application, I do need to do a couple things. If I simply delete this replica set, the pod will just come back. So before I do that, I'm basically going to disable our scheduling. So we're going to cordon these off, and that basically
temporarily disables the scheduling purpose, so it doesn't just bring the pod back. So now that we have disabled scheduling, we can go over here and we are going to delete that replica set 10, the primary. You can see it terminating. All right, 60 seconds in, let's go take a look at the database. Let's refresh this. It is still listed as primary. It will take a moment to fill over. All right, and now we can see that our replica set 10 is down, right? And it looks like our replica set 2 has taken over. And if you remember correctly, that was over on the Azure side of things. And we can see the replica 2.0 has taken over. So that is now the primary data set. So if we go over to our Azure instance, view that high score list, it's still there. Let's play a new game. We're going to make at least 700 on our score. All right, and this is Azure at 3:49 p.m. Save. There is our score that we just made a moment ago. And we can go over to our AWS. And you should see that score up there too. And that's pretty much it. So thank you very much for your time today. As you can, let me just summarize what we just saw here. We had our deployment of Mongo across 3 clusters in AWS, GCP, and Azure. We're able to run that application pointing at that one common database, 3 replica sets, and we're able to kill one of those replica sets, and your application was still able to take over, all due to the simplicity of networking through KubeSlice. Thank you very much.